Welcome back. So today we're going to be working on 11.2, the quadratic formula. So I do have some notes here for us before we get started. So the quadratic formula, if we have an equation in the form ax squared plus bx plus c equals 0, which is like what we were talking about yesterday in 11.1, then we can find the roots by using the quadratic formula. And so that is our x equals the negative b plus or minus the square root of b squared minus 4ac. All of that is divided by 2a. Okay, so then just a couple of notes that go along with this. The a is the coefficient to our x squared term. Okay, so that's the number that's in front of the x squared. B is the coefficient to the x term. So again, that's the number that's in front of the x term. And then c is our constant. So that's the number that's by itself. Also, the plus minus is used to combine two expressions into one. So an example of that, if we had a plus or minus 2, that's the same thing as a plus 2 and a minus 2. So we're just combining these two expressions into one when we write this. Okay. All right, so the first thing that we're actually going to do is we're just going to be looking at our trinomial, and we are going to identify the a, the b, and the c. Okay, so if we look at this trinomial, we said a is the coefficient to the x squared term. So we're going to look here at the x squared. We want to look at the number that's in front of it. So a is 3. The next one is b. B is the coefficient in front of the x term. Now, if you look at this one, there's no number that's actually here. But if there's no number, then we always know that to be a 1. So our b would be a -1 since there's a minus sign there. And then the last one is c. C is the constant. So if we look here, we have our c, and that one is going to be a -7. Okay, so like I said, the first part is just identifying your a, b, and c, and then we can start plugging it into our quadratic formula in order to solve and find our roots. So that's what we're going to do with this next example. All right, so our next example that we have here, we are actually going to solve the trinomial x squared plus 5x minus 14 equals 0. Okay, so we already have it in that format, the ax squared plus bx plus c equals 0. So the first thing we're going to do is we're going to identify our a, our b, and our c. I'm just going to write them over here. So a is the coefficient in front of the x squared. So since there's no number here, remember that always means 1. We just have 1x squared. B is the coefficient in front of the x term. So that would be a +5. So we're just going to write 5. C is our constant. So for this one, that's going to be a -14. Okay. Now that we have all of those identified, we're going to come back up here and look at our quadratic formula, and we're going to plug in all of those values. Okay. So I'm going to go x equals negative b, which is 5, plus or minus square root b squared, so that's 5 squared, minus 4 times a is 1, times c is a -14, and all of that is divided by 2 times the a, which is 1. Okay, so all we did there was we took all of these numbers and we substituted them into our quadratic formula. And again, that was up here. Okay, so now we're actually just going to solve and find our two roots. All right, so the first thing that I'm going to do here is I'm going to be looking at my exponent. I'm going to be simplifying stuff. So -5 plus or minus 5 squared is 25, minus, I'm also going to simplify this piece over here. So we've got 4 times 1 times a negative 14. Okay, so if we have 4 times 1, that's going to be 4. And 4 times the negative 14 would be a negative 56. But we also had a negative up here. Negative times a negative is a positive. So this is going to be a positive 56 over 2 times 1 is just going to be 2. Okay, so then the next step, we're going to combine what's underneath of our radical sign. So we've got minus square root, minus 5 plus or minus the square root. 25 plus 56, we end up with 81. All of this is still divided by 2. Okay, next thing I'm going to do is I'm going to take the square root of 81. So x equals negative 5 plus or minus square root of 81. It's going to give me 9 divided by 2. So now from here, I'm going to split this up into 2 different equations. Oh, I apologize. You can't even see that. So I had negative 5 plus or minus the 9 divided by 2. So now I'm going to come over here and I'm going to split this into 2 different equations. So I've got a negative 5 plus 9 over 2. And I've got a negative 5 minus 9 over 2. Okay, so then to solve both of those, a negative 5 plus 9, that would give us 4, positive 4 over 2, which is 2. Or negative 5 minus 9 would give us a negative 14 over 2, which would be a negative 7. Okay, so these are our 2 different options. So then the last piece is we need to actually check and see if those work. So if you remember in the last video, we had to plug it back in and check each one of them. Let's see here. So I'm going to come over here and I'm going to check the 2. So I'm going to go 2 squared plus 5 times 2 minus 14. 2 squared is 4. 5 times 2 is 10 minus 14. 4 plus 10 is 14 minus 14 gives me the 0 that we wanted. Okay, so this one works. So that's a good one. Now we're going to try the negative 7. So we're going to go negative 7 squared plus 5 times a negative 7 minus 14. Negative 7 squared is going to give us a positive 49. Negative 7 times 5 is actually going to give us a negative there. So minus 35 minus 14. 49 minus 35 is going to give us 14. Minus 14 would give us our 0 that we wanted. So that one works as well. So these are both real roots to our equation that we have up here. Okay. All right, this step here, this check piece, this is actually really important because sometimes you're going to find that it doesn't work. And if it doesn't work, it's not a real root. Okay, so you have to be sure to double check that piece. Okay, I do have a couple more examples that we're going to do here. This first one, this one is not set up like our ax squared plus bx plus c equals 0. So we're going to have to move some things around first. Okay, so in order to get that to look the way that we want it, we're going to have to subtract the x and subtract the 21 from both sides. So we get 2x squared minus x minus 21. And then that equals 0. So now we have it set up the way that we want it. We're going to identify our A, our B, and our C. So A equals, that's the coefficient with the x squared, so that's 2. B equals the coefficient with the x, so that's -1. And C is our constant, which is a -21. Okay, so now that we've identified A, B, and C, we're going to plug it into our quadratic equation. So we're going to go x equals negative b, so it's going to be a -1 plus or minus the square root b squared, so -1 squared minus 4 times a, which is 2, times c, which is a -21. All of that is divided by 2a, and a is 2. Okay, so there is our equation. So now we're just going to go through and start simplifying everything. So starting here, negative times a negative would give us a positive. So this becomes a +1 plus or minus the square root. -1 squared would be 1. Then we're going to take -4 times 2, which is a -8, times a -21. Negative times a negative is a positive. Times the -21 would give us 168. Feel free to use your calculator there. Don't do that in your head. You don't need to. Divided by 2 times 2 is 4. All right, so we're going to keep on going with simplifying here. X equals 1 plus or minus the square root of 169 over 4. So then this is the step where we're going to do our square root. So x equals 1 plus or minus the square root of 169. We type that into our calculator and we get 13 over 4. So now we can split those up into two different equations. 1 plus 13 over 4 or 1 minus 13 over 4. All right, so when we do plus the 13, we get 14 over 4, which reduces down to 7 over 2. I'm going to leave that as an improper fraction. The next one that I have here is 1 minus the 13, which is a -12 over 4, which gives us a -3. The next step here is to check. I'm going to slide this over just a little bit so we can check. I'm going to come up here and we're going to go 2 times our x squared, 7 over 2 squared equals 7 over 2 plus 21. And then we're going to simplify. So I'm going to leave that for you to check. So go ahead and plug those things in. If you prefer to change the 7 over 2 into a decimal, since this is a terminating decimal, that would be fine. The other one that we're going to check is going to be 2 times our x, which is a -3 squared equals -3 plus 21. So those are the two equations that you're going to check. I'm just going to write check up here. Okay. Like I said, I'm going to leave those for you to check. Make sure that both of those work. If one of them doesn't work, remember that that is, you could have made a mathematical mistake, so make sure you go back and check your work there. But it could also be that it's not a real root. Okay. All right, so the last example that I have for you guys today, this one is set up with our ax plus, or our ax squared plus bx plus c. It is already set up that way. So we've got 3x squared plus x minus 5 equals 0. So step 1 is just identifying a is 3, b is 1, c is -5. Then we're going to plug it into our equation. So x equals a negative 1 squared. And then we're going to go plus. I'm not sure why I put negative 1 squared there. I apologize. I was thinking about inside the radical there. So we're going to go negative b, which is 1, plus or minus the square root of our b squared minus 4 times a times c. I just really wanted to make that one negative. I'm not sure what I was thinking here. He just really wanted to be negative there. Divided by 2 times our 3. All right, so we've got our negative b plus or minus b squared minus 4ac over 2a. And then we're going to go through and simplify. So I've got x equals a negative 1 plus or minus the square root. 1 squared is just 1 minus. Actually, this is going to end up being a plus because we're going to take a negative 4 times 3, which is a negative 12, times a negative 5. So a negative times a negative is a positive, and that's going to give us 60 over 2 times 3 is 6. So then from here, we're going to go ahead and simplify inside of the radical. X equals negative 1 plus or minus the square root of 61 over 6. Now, this is where this one is a little bit different from the ones that we did before. The square root of 61 is not a perfect square. It's not going to come out to a whole number. It's not a nice one like what we had before. So this one's actually going to end up giving us a decimal. So anytime it does that, we are going to be rounding to 3 significant digits. Round to 3 significant digits. So when I type this one into my calculator, square root of 61, I end up with x equals a negative 1 plus or minus 7. There's 1 significant digit. 8 is 2. 1 is 3. And there's a 0 after that, so it's just going to stay the 1. So like I said, 3 significant digits there. So I've got 1, 2, 3 significant digits. Okay? All right, and then we are still dividing by 6. So again, this is the stage where we split that up into 2 different equations. So we're going to have negative 1 plus 7.81 over 6 and a negative 1 minus 7.81 over 6. So then again, we're going to have to punch those into our calculator. On the left side here, we're going to get 6.81 over 6, which is 1.14. Scoot this up just a little bit here so you can see where I'm at. So I took the negative 1 plus the 7.81. I got 6.81 divided by 6, which is 1.14. And then on this side, I have a negative 8.81 over 6, which gives me a negative 1.47. Okay. All right, so then again, you are going to be checking those. So make sure you come up here to the original equation and do your check. So 3 times our x would be 1.14 squared plus 1.14 minus 5. And then the other one that we're going to do is the negative 1.47. So you're going to take 3 times negative 1.47 squared plus a negative 1.47 minus 5. And we're going to check to make sure both of those come out to 0. Again, I'm going to leave that for you to check. Okay, that is all the examples I have for you today. The assignment that I have for 11.2 is page 353. You're going to do numbers 1 through 33, every other odd. If necessary, again, we're going to be rounding to 3 significant digits. So the first 2 problems that you should see in your practice are just asking you to identify A, B, and C. You're not actually using the quadratic equation yet. So just finding A, B, and C there. Then starting on 9, you're going to use your quadratic formula. 9 and 13, you shouldn't have to round anything on those, but starting on number 17, so 17, 21, 25, 29, and 33, those you may potentially have to round on those. Okay, so I'm just going to slide this over here so that you can see this right quick. So that is your practice. So 1, 5, 9, 13, 17, 21, 25, 29, and 33. All right, that is all that I have for you today. Have a great day, and I hope to see you in class tomorrow. Bye.